Okay, good morning. Hi, it's early. We're all here. We've all had some coffee. It hasn't kicked in yet. Great. Okay, hi, my name is Alex Riviere. I am a senior web developer for Nextcore Food Safety Management. We make software that you have benefited from and have never used. I am here today to talk about debugging and maybe make you a better person at debugging or troubleshooting issues that come up with your code. As some background, I started programming in the early 2000s, and then I took a slight detour and did theater for 15 years. So during that time, I started off as a performer, and after a certain point in time, I kept getting calls to be a technician and not to be an actor. And I went, why am I wasting my time on acting? I should be a technician. So I did that. For 15 years, I worked in theater. This is an image from a play called Mrs. Bennet, Christmas at Pemberley. It was a production we did at Theatrical Outfit in Atlanta. It's written by Lauren Gunderson and Margot Melkin. If you ever get a chance to see a production of the show, you should absolutely go. But this is a lighting design that I got to do, and it was very fun. And so I've done lighting design. I've done lighting setup. I got to go touring for a bit with a small opera company called Peach State Opera. I helped with various shows. I think this one was taken at Georgia Shakespeare Festival. I was helping set up the lights for that. This is me and my friend Pocket being very OSHA compliant. The ladder wasn't long enough to reach the lights, so this is staged. It's not actually, we weren't actually doing that, but I sent that one to my wife at one point, and she went, no. But a lot of my job was troubleshooting lighting systems, and sometimes sound systems, and sometimes video systems, and knowing where is the problem in all of this, right? And like figuring out like what are all of the things that make the problem show up. And so we spent a lot of time troubleshooting various things. This is a prehistoric slinky that we discovered on an archaeological dig. They were much bigger back then because there was more oxygen. It was a megafauna slinky. Now, this is actually a spring from a orchestra pit that has been removed, and it was a good photo opportunity. And so when I'm thinking about troubleshooting, my mental model for troubleshooting code becomes a very tactile thing for me, because I take it back to the theater stuff that I did and sort of tracing where is the signal being lost along the way. So we're going to talk about debugging your code by using a metaphor that everyone, hopefully, who's watching this has encountered. We're going to talk about changing a light bulb. Who here has never changed a light bulb? Good. Common ground, that's what I want. So, when we're talking about light bulbs, we need to first identify the problem, and the problem in this case is the light bulb is out. The light bulb is not turning on, right? Why is the light bulb not turning on? Now, at this point, you might be tempted to call the power company. No, you're not. And so if you are in code and you have a bug, first you need to identify the bug and try to figure out where it is and where it's coming from. But if you have a bug in your code and it's an error being thrown by, I don't know, React or something like that, you shouldn't immediately take that error and go make an issue on the React GitHub repo, because that would be the equivalent of your light bulb going out and calling the power company. It's not good practice. You should first make sure that what you're doing is correct. So first part is that we need to identify the bug. The light is out. Maybe you've figured out, hey, this function that I'm calling isn't doing the thing that I'm expecting it to. Or maybe you're getting a random error being thrown about suspense mode and you don't know what that means. That's fine. We have tooling that can help us identify some of these things. One of the big things that you should be using is a stack trace to be able to find stuff. If you have an error, it'll help you pinpoint where in your code the error is, right? Maybe you don't want to, like, if you look at a stack trace, and I don't have any examples of this at the moment because it's very language dependent, but typically most languages have some concept of a stack trace. And in the stack trace, the first line where the error is thrown is probably not where the error is, right? The reason that we have a stack trace is that you've called something, and so there's extra things on the stack, and so we're going to look back up through the stack and find the first point where it's actually code that you write, and that's probably where the bug is coming from. So knowing how to read a stack trace is an extremely good thing to do. There are many guides out there for the specific language and tooling that you are using. You should look them up and use them as resources. I'm not going to talk about that much more because, once again, it's highly language dependent upon where that message is and how to get to that message and what that message says. But just know that's a tool in your back pocket that's just there, always available to you to use, so use it. Well, now that we've identified where the problem is, the light bulb is out, we should do some digging about it. First thing we should try is to swap the light bulb out, right? We've all done this. Light bulb won't turn on, and screw it, put another one in, see if that one turns on, right? The code equivalent of this is find a working example of the code you're trying to do, right? Somebody else somewhere has probably written it, unless you wrote everything by yourself with no help, in which case, good luck. But somewhere else there is likely an example of what it is that you're trying to do, right? So go find a working example, compare notes, and be like, is this the right thing? Like, am I doing this right? Because sometimes that's all you need. Maybe you realize, like, oh, actually I'm calling the wrong method. Maybe you're not actually using it correctly, right? Maybe you missed a couple of steps. Who knows? Another way that you can sort of do this similarly is write a test, right? All of you testing nerds out there are probably going like, you should write the test first. No. Sometimes we discover something, and so it's good to write a test to be able to show, hey, let's double check that everything I'm trying to do should work. So, write a test, be able to prove it out. The key to this, though, is to create a controlled environment, right? You want to sort of eliminate stuff until you can create a controlled environment. And so writing a test is a good example of that. Finding another example and seeing how that's running there, that's a good example of that. So step 2.5, we'll call it, is taking the light bulb and putting it in so the original light bulb, we put it into another lamp, right? So first, we're going to take our bulb that doesn't work, and we'll take a new bulb that may work, put it into the original lamp, and then we'll take the original light bulb, go try it in another lamp, right? Maybe the light bulb's not the problem. Maybe there's something else. So just sort of testing all of our options. And so some of this is like looking at the data that you have coming in. What are you playing with? Where is that data coming from? Make sure that your assumptions about your data are correct. And a good way to test those assumptions is to use a debugger. Once again, not going to have an example. It's highly language dependent. Python has PDB. I think C# has like built-in debugging tools to like Visual Studio. JavaScript has stuff. So debuggers are great because it shows you in that tooling like where you are in the call stack. What scopes do you have available? What variables are in the scope? And you can start poking around at values, and you can kind of make sure, like, is this thing actually defined? Do I have an undefined value, or a null value, or a null undefined value? You can also do this a slightly easier way, which I think when I say this next one, all of the testing people will scream. You can just console log it. It's always very fantastic. Does it get here? Here? Here, right? Like, figure out where in the code it's actually stopping. So this is another tool. It is a perfectly valid way of doing this. If anybody says you should stop doing this, ignore them. It works fine most of the time. Occasionally, you do need something more powerful, but this is a perfectly valid way to debug things. That being said, I do it all the time. All right. So we've now sort of figured out, identified where the code is, figured out what the environment is happening around the code that is not working, right? Great. Well, the next step of this is that we need to test the lamp. Maybe the lamp itself is bad. Maybe the light bulb's good, the lamp is bad, maybe you're having problems, right? So we needed to go take the lamp from where it's currently plugged in and go plug it in somewhere else, right? That outlet probably works. How do we do this in code? Well, the equivalent is make sure the data source is returning the correct data. Maybe you're calling an API. Maybe you're calling a database. Maybe you're looking through a file system, right? Maybe you're getting user input, and the user input is being transformed before you get to it, and you don't realize that, and your date format's in the wrong thing, and JavaScript gets angry, and then you're off by 12 hours because JavaScript, right? Like, it's a whole thing. It could be anything. Not that we've run into that recently. Not bitter. Abby might be. We can also, at this point, write an integration test. And once again, testing nerds are going to be screaming, write the test first. Yes, I know. Not all of us live in your little bubble. Writing an integration test gives you the ability to test all the way through where you're getting the data from, right? So if you're calling an API, test that API interface. Make sure it's getting stuff from wherever it's getting stuff correct. Go write a test that tests how your date input works. Make sure that the database is actually returning the data you're expecting it to, right? Integration tests are great for this. They kind of help document that stuff, because documentation is important. So yeah, it's another great way to sort of document your process, show your steps, as they would say in math class, show your work. So we've tested the lamp in a different outlet. So the next step is maybe it's the plug, right? Like maybe it's the actual outlet itself, or maybe it's part of the lamp, right? Maybe you just need to like cut that off and put a different thing on. Maybe you need to swap out the wall receptacle. So we're going to check the plug. The way that we do this is that make sure that you're connecting to the right resource. Yes, you're calling the API. Are you calling your localhost API? Or are you calling dev? Or are you accidentally calling production? And you have a bunch of CORS errors because of it, right? Like, it could be lots of different things. So make sure that your data source is correct. If you're just calling a database, maybe you're not connected to the right database, right? Also, if you have it, check the documentation. What is it that you are supposed to be connecting to, right? We don't necessarily have documentation all the time. So sometimes you might have to dig through the code, go ask somebody and be like, what am I supposed to be doing? And make sure that you have some sort of way to find out this information. So documentation is great, and so we're needing to check the plug. We're sort of getting data at this point from some, like a outside resource sort of a thing. So step 4.5 is, once again, take a different lamp, right? So we're testing the assumption about the plug. Take a different lamp, whole fixture, whole unit, and we're going to plug it into a different, or we're going to plug it into the original plug, right? So if we know that plug works, but we don't know about this one, take something we know that works, put it into that plug. And the way that we do this in code is you have a problem, create a minimal reproduction of the problem so that you can show it to someone, right? And sometimes in creating that minimal reproduction where we just sort of eliminate as many variables as we can, and we go, hey, I need it to be just this thing and the minimum amount to make that thing happen, you sometimes discover, oh, I missed a step, right? Or maybe you didn't miss a step. Isolating, though, can help you, once again, pinpoint exactly where things are breaking. And this is important because of the next step. It'll make sense in a second. But minimal reproductions allow you to sort of test on that in a isolated environment where you're not having to worry about well, the CSS is wrong and actually everything on the page is hidden and I don't know, stuff's not working, right? We can really narrow it down to just this one thing. So once we've tested the light bulb, the lamp, the plug, right? We've tested everything up from there to here. We now have to go a little bit further. You should check the breaker box, right? If the outlet's not working, maybe you tripped the breaker. Maybe something else on the same circuit tripped the breaker, right? So you have a breaker box. Maybe it's just not getting any power. So part of this is we've been talking about outside resources, and the plug kind of represents outside resources. And at this point, if you have a minimal reproduction and you've narrowed it down and it's probably not your code, it might actually be a bug in an outside package, right? Maybe you hit the lottery edge case, right? You're the 1 in 1,000 people who goes I'm going to do this weird thing, and it goes no, and you're like, what? Right? You have found the bug. So one of the things to do at this point is to check your package versions. Let's make sure that you're actually using the right documentation for the version of the package that you're using, right? If you're using the documentation for version 3, but you're actually using version 2, you're probably going to have problems at some point. So make sure that you're using the right documentation. But also, maybe it is actually a bug. Maybe it's a legitimate bug. And maybe you're not running the most up-to-date version of the package that you're using. This is where release notes are very handy, because sometimes you can just go to the release note and they'll be like, oh yeah, we ran into this weird thing where if you do things this very specific way, it causes a bug, and hey, we fixed it 2 minor versions ago, right? Great. Bump up your package version. Problem solved. Yeah? So sometimes it's actually not you. Most of the time, you did do something wrong, but sometimes, legitimately, it's not you. Once you've checked the breaker, right? So now we have checked the light bulb, the lamp, the outlet, the breaker. We have reached the point where most people will call a specialist, right? If we're debugging a light bulb and we have run out of options of things to test along this path, we need an electrician. Now, some of us are handy, right? Maybe you are willing to start digging into your wiring and figure out where the issue is. So what this looks like in code is go find someone who's more senior than you and ask them for help, right? If you are struggling, if you have reached this point in your code debugging journey and you haven't asked somebody for help, now is absolutely the time that you should. This also can look like if there isn't someone, maybe this is a larger issue, maybe this is a larger thing that you're going to need help with, and maybe you work for a company that has deep pockets, you can call a consultant, right? There are people who have highly specialized knowledge of the specific thing that you are using, likely, and they may be able to spend 30 minutes, do everything that you just did, look at it and go, change one thing, problem solved, right? Consultants are invaluable a lot of times because they can sometimes just come in, look at stuff, and fix it. I have been a consultant who has done this for front-end view stuff, and let me tell you, the people who I do this for love it, because I used to be called the loaded gun, because they would get everything set up, and they'd be like, Alex, what's wrong? And I'd walk in, and I'd go, change one character, there you go, and I would walk away. I liked it because I could be like, that is an hour of time, and I can... Now, let's say you are trying to troubleshoot your light bulb, and you are one of those handy people who feels like digging into your own wiring, and maybe the package that you're using is open source. Now is a great time to contribute back. This is the point at which you can file an issue and say, hey, given this minimal reproduction that we've already made in the previous step, I can cause this bug to happen reliably. You make that be an issue for the open source project, and then, being the handy person who likes digging around in the wiring in your walls, you can then make a PR, contribute back to the project, and give them a bug fix for the bug that you have found. This is great because open source is difficult. It doesn't make a lot of money if you are just running an independent project by yourself most of the time. And you can contribute back, and that is what makes open source go. All right, I'm going to take a quick drink break here. All right. The next step is we're going to have to look at what's happening inside the wall. We have to troubleshoot all of the wiring that's happening behind a wall. This typically means ripping out sheetrock. Occasionally, depending on how things are wired, you might have to go get a jackhammer. Oh, darn power tools. I feel like there are so many people here who has children who are like, I want to use a jackhammer, right? That'd be some people's dream. So this sort of ties into the last step of being able to dig into how the open source code is working, contributing back to it. But sometimes it's an opaque wall, right? We don't have a way to access that wiring. And similarly, in some libraries that we use, we don't have access to that code. So we can't contribute it back. At this point, you should reach out to the maintainer, right? So maybe it's an independent developer, maybe it's a large corporation, right? But they typically have some sort of feedback mechanism where you can say, hey, minimal reproduction, here's the bug that I'm seeing, can you fix it, right? And can we get this into a new release? And it has been my experience that they're very responsive when you're able to come in and say, here is the code you need to reproduce this bug reliably, and it gives them the ability to dig in on their end to fix it. Now, sometimes the issue is actually completely out of your control, right? There are times that things are just out of your control. Maybe while troubleshooting this light bulb, you failed to notice that nothing in your house is on. The power's out, and you just don't have power at the moment, and that's why the light bulb's not turning on, right? That's definitely a possibility. You just get so involved, you forget to are the lights on in the rest of the house, right? But it could be, something else, like maybe it's just localized to you, right? Maybe something happened outside, you got disconnected from the power grid, and so check for a system outage, right? If you are having issues with authentication, maybe Microsoft is having a bad day. It happens. Maybe GitHub's down. That definitely happens. Maybe NPM is having a bad day. That happens a lot. It's one of those things where it may not be something that is actually in your control, right? Maybe your database provider is down. Maybe your auth provider is down. Maybe your hosting provider is down. Maybe the CDN has got a bad DNS configuration and they're having to go get the spinny wheels of doom to get into the server closet because everything's tied to the login for their system on the system they just disabled, Facebook. So yeah, sometimes it's a system outage. Best way to look at this is go find a status page. A lot of services, if you're using it pretty regularly, they will have a status page to say, hey, we do actually see that there's a problem, right? Now, sometimes if you go look at that status page, they're like, it's all good. We have 0 problems, 99.999999999% uptime, baby, right? And you're like, that's not true. But at that point, maybe it is localized to you, so you should call the power company, right? Maybe the transformer right outside your house blew up. Maybe the cable going out to the street is disconnected, and you've got a live wire out on the street flailing around and zapping cars as they drive by. So this is the equivalent, once again, of looking to see if you have a service level agreement with some provider, like if your company has a service level agreement, this is a great time to utilize that and call them and go, pardon, right? This is why you have service level agreements, is specifically so that you have a person you can call when something like this happens. Now, sometimes maybe it's a personal project. Maybe it's a side thing. Maybe you're using a service that a friend hosts. I don't know. But if it's a smaller service, once again, you should file a ticket and say, hey, I'm having troubles getting into the system. Can you help me? And usually, if the person is reasonable, they'll respond to it and be like, yeah, sorry, there was a bad configuration. We'll have it back up in a couple of hours, right? So at least then you have a time frame for how long you're expecting things to go. If at this point none of this has worked, what you are left with is flipping a table. At this point, you should just give up, right? I think that the best advice, if you have reached this point, is that you should just run into the woods. Live your life as a bear, forage for berries, and just live out there in nature. Alternatively, you could also become a farmer. I hear at one point, I think New Zealand really needed sheep farmers. That's a thing you could absolutely go do. New Zealand is beautiful. You know, that's probably your best option. It's not your best option. Sometimes when we're troubleshooting, we realize that maybe we missed a step. And so once you take a step back, you take a breather, right? Everything seems like it's wrong. You can take a step back, think through it all again, and realize the step that you forgot to take. Sometimes you should just check your spelling. That is my talk. Thank you for coming. Are there any questions? Fantastic. I have wowed you all over. I'm looking to see if we have any. Nope. Okay, cool. One up there? Yeah. So the question is, if I could talk more about making a minimum example, which is a good question. It depends, right? That's my senior developer answer. So for instance, a minimal reproduction would be in front-end terms. Let's say you're having a weird CSS issue, right? You're trying to get, I'll make the annoying joke, you're trying to get a div to be centered, and it's not wanting to center, right? So what is the minimum amount of the markup that you have that you can do that causes the issue, right? If you're talking about like a div in your content section, you probably don't need the header, probably don't need the footer, probably don't need the sidebar, right? So like, get rid of those, right? Just take everything in the middle. Take the same CSS that you have, and then just start eliminating things. Like, okay, I don't need this, I don't need this, don't need this, right? And get it to where you can make the thing that's being weird consistently happen, like on every page load, right? Like, yep, nope, it's always like 50 pixels off center, right? And then you can be like, okay, cool. What is causing that? And then you can diagnose it because you're not worrying about like everything on the page. Sometimes though, it is caused by everything on the page and you do know everything. And then you should probably, at that point, it's probably a more like, let's rethink how we're handling this thing, right? Like we've over-engineered it. Maybe we can remove a few layers of the onion. In JavaScript or any programming language, this might look like, depending on, like if you're front-end JavaScript, CodePen, fantastic tool for this. Being able to, codepen.io, you're welcome, Chris. They have a way to basically, they give you a script section, a CSS section, and an HTML section. And you can, if you can recreate the problem in there with just the stuff in there, it's a lot easier to say, hey, here's this problem that we're having. Similarly, if you're needing to do back-end stuff in JavaScript, I think Stack Blitz, codes, or Code Sandbox, or there's another one that I'm forgetting about, where you can basically go, here's the minimum amount of stuff with like dummy data to show like I'm having a weird problem. You can also use, like if you're in Python, it would be like, okay, reducing how many things that we're using and like putting it in a REPL or something like that. And maybe it's something that you just do within your own code base. So like make a separate file, right? Like we have a bunch of stuff in this JavaScript file. Great, I'm gonna make a separate file that just imports this one thing and this one thing and then call them two together and then see what happens, right? Like that's how you should go about doing it, is like, what is the littlest amount of code I need to make this bug trigger? And it's not a quick, like, oh, I'm just going to copy and paste some stuff. It can take some time. It can take a few hours. Sometimes it can take days because you're having to like pinpoint exactly where the issue is. And so it's not always feasible to do this, right? All of these steps can be done kind of in any order. I suggest doing step 10 earlier, maybe like as step 2. I don't know. Checking for typos tends to be a common thing that causes issues. But if you had a minimal reproduction, it would be easier to be like, let me get the definition of this variable, right? Like, let me do const var name, and you bring it in, and you realize, oh, no, I called var name, right? And you put an E instead of an A. Problem solved, right? You've put the two lines right next to each other, and suddenly it's a lot more obvious what the issue is. So sometimes it's just about, like, really, like, making it into, like, what is the smallest thing that causes this issue? Hopefully that answers your question. Cool. Anybody else? Excellent. Well, thank you all for coming to my talk, and I hope you have a great rest of the conference. Yay!